Hi ladies and gentlemen, I hope everyone is doing well tonight. So today we are looking at trends in size. So the first thing you'll notice when you look at this is we have some Bohr diagrams. We have Bohr diagrams for boron, carbon, and nitrogen. The first thing I want to point out is that the nucleus charge is equal to the number of protons. So in boron we see we have a nucleus charge of 5, it's because it has 5 protons. Carbon has a plus 6 because it has 6 protons. Nitrogen has a plus 7 because it has 7 protons, and so on and so on. The trend would continue. So next you would notice that the first sentence is underlined. So the first sentence, this is your definition for charge attraction. So everyone should write down charge attraction and shielding onto their definition sheets. You can pause it now to write them down. But charge attraction is the positive force from the nucleus that keeps all of the electrons in orbit around it. We talked about this earlier, I just never gave it a name. Shielding is when we have inner electrons blocking out some of the charge attraction before it reaches the outer electrons. So if we take a look at the first examples, we can look at carbon. So if we were trying to figure out the charge attraction on the outer energy level, we would have to see that these electrons are shielding. So you have to remember that these electrons are negative, so they are super attracted to the nucleus. They're also negative, and we have to remember that negatives repel each other. So think about like a magnet. When you put two positive sides of a magnet together or two negative sides of a magnet together, they repel each other. Same principle happens here. These electrons push back on these electrons a little bit. However, the charge attraction is much greater than the charge of one electron or two electrons, so they are still held in orbit. But that's what shielding is. Shielding are the electrons in between the outer energy level that are blocking some of the charge attraction. So you can always calculate charge attraction fairly easily. So charge attraction is always equal to the number of protons minus the number of electrons that are shielding. So if we were to calculate it for boron, we would see that boron has 5 electrons. If we're looking at the outer energy level, we have 2 electrons that are shielding. So we would do 5 minus 2, which would give us a plus 3. Next, we can do it for carbon. Carbon has a plus 6 protons. It has 2 electrons shielding, so minus 2 give us a plus 4 charge. So next you can do it for hydrogen. Using this information and some of the information from old Chemquests, such as an electron's address, you can find information on energy levels, sublevels, and orbitals, and Bohr's atomic model to be able to draw Bohr diagrams. You can answer questions 1 through 8. So pause the video while you work on those questions. So the next section is charge and distance. So first thing I've highlighted is opposite charges attract. So that's like our magnet again. You put a positive to a negative and they'll stick together. Same kind of thing here. So we're looking at a positive 3 charge and negative 3 charge. This arrow represents attraction and distance. So now we look at positive 4 and minus 4, same attraction, just less distance. And then positive 5 and negative 5, attracted, even less distance. So as we see, positive 5 and negative 5 have the smallest distance because there is the greatest attraction. So that means there's less distance between the two spheres. Same kind of thing with people. So think about it. If you are really attracted to someone, you want to sit next to them. You want to be close to them. So the stronger the attraction, the closer you're going to try to be to that person. Same thing with metal spheres, same thing with electrons and protons. So the next thing I want to highlight is from the previous page, you already calculated that boron feels a plus 3, carbon feels a plus 4, and nitrogen feels a plus 5. So this charge attraction directly relates to how big an atom is. We see that if the charge attraction is strong, then the atom is small. If the charge attraction is weak, then the atom spreads out. Remember, charge attraction is not too hard to calculate. You can remember that the charge attraction equals the number of protons minus the electron shielding, and then all you have to do is compare charge attractions. So the larger charge attraction will be smaller, and the lower charge attraction will be bigger, kind of an inverse relationship. So we know that out of boron, carbon, and nitrogen, nitrogen is the smallest, and that's because it has the largest charge attraction. So now that you know a little bit about charge and distance, you should be able to answer questions 9 through 13. 13 can get a little tricky. 13, you're thinking about the general trend that happens as we move across a row or a period in a periodic table. So as you're thinking about this question, think about what increases as we go across a row and what would that affect and how would it affect it. That'll help you answer 13. So then next we are on some Bohr diagrams and size of the atoms. So we're looking at some Bohr diagrams for atom A, B, and C. I highlighted atom because that tells us that protons equal electrons. So in that way we can easily answer stuff like question 14. So in question 14, we can figure out that there are 11 electrons, so the atomic number is 11, that's sodium. Lithium is the atom B because it has an atomic number of 3, that's lithium. And then hydrogen 1 because it has 1 electron, so it has 1 proton, so then it must be hydrogen. Using these Bohr diagrams, you should be able to answer the next couple questions, 15 through 21. A couple things that I want to point out is that if we look at lithium, sodium, and hydrogen on a periodic table, so right here we would have hydrogen, lithium, and sodium. The things that I want to point out is that all three of these are in the same column. Remember, if they're in the same column, we know that they must have the same number of valence electrons. Remember, valence electrons are the outermost energy level. So because they have the same number of valence electrons, they also have the same charge attraction. So there's something else that's affecting the size of the atoms. When you're looking at these questions, think about what increases as we go from atom C to atom A. Which one just looks bigger? And that will help you answer these questions. So a couple tricky questions are 18 and 20. So that's kind of what we were just talking about a little bit. We know that A is larger than B. So when you're looking at A and B, what does atom A have that atom B doesn't? And then 20 is very similar. So then think about what you just said for 18. As you move down a column, what increases? And then that will help you answer this trend. Please answer every question. If you have any questions, bring them to class and we'll take care of it from there. Hope everyone has a good day.